Hello everyone. My name is Nelson Gonçalves. I'm a software engineer, backend software engineer in Pipedrive for about 1 year and a half. So today we'll be talking about microservices and how they affect our day-to-day as developers, not about the actual architecture of a microservice. So everyone has an idea about microservices. Basically, they appeared as an alternative to the monolith architecture. Basically, when you have a cluster of different services that operate together as an orchestration to reach a common purpose. So the idea is that having the logic spread around multiple services, you can basically have a more limited logic in each one of them. So it's more contained, it's easier to test, and it's harder to make mistakes, basically, if it's not everything in the same place, which facilitates kind of hacking behavior inside the application. So this looks good, but there's always downsides for everything, right? So for microservices, the biggest downsides is that if you are having multiple services, you need them to communicate, right? So you have to build a whole layer that basically will allow you for the microservice to communicate with each other, to basically operate as seeming as they were only one for the end user. So this is a whole layer of complexity that is completely new. Another issue is that since you are launching multiple services, there are a bit of behavior that is shared between all of them. We are talking about health checks. We are talking about how they communicate with each other. It follows the service communication layer, and a whole lot of things that you'll find that you need in your infrastructure and are common to every single of your services. Other thing is infrastructure complexity, right? If you have 1,000 microservices, you will have a big cluster of services to manage instead of just deploying your big release of a single monolith. And last but not least, we have to track the dependencies of all the services, how they work together, how they cooperate, if they are not too tightly coupled. So what can we do about those issues? How can we make sure that they are as less painful as possible for our day-to-day? So starting with the communication layer. I don't want to be really specific how we implement it. We can use like queues, we can use direct HTTP requests, anything that's it's communication. It depends on what the service intends to do. So the only thing that we must make sure is that every single service is available for the others, right? So we need to make sure that they can find each other and there's always one service that is available. So we also need to make sure that they all talk the same language. They all have a set of contracts that they always respect. So what can we do about this? So they all know where each other they are. One of the possibilities is using service discovery. This is mostly helpful if we are dealing with asynchronous requests. If we are using queues, the message can just stay there, and probably that won't be an issue. It depends on the goal of the application, but it might not be an issue. But if we are talking synchronously, we must be sure that we can find a service that can be found. To make sure of that, we need to have health checks of all those services. So we must have a centralized place that's basically a source of truth about what services are for a given, what instance of a service there are for given services and where they are located, basically. So with that, we can simply plug and play services, register them there, and basically they can communicate easily. Considering the contracts, one of the possible ways is to keep like something like a library. It doesn't need to be a library, but something that basically is a source of truth to every single communication pattern that exists between them. Also, it's really important to have a single way to update the contracts in every single service at the same time to make sure that there are no inconsistencies between the current contracts in each one of them. So, shared behavior. There's the infrastructure part and the business part. By infrastructure, I mean, we already talked about health checks. Basically, every single service that we ever do will need to implement health check, right? So business logic is more like the contracts, for example, is a way of business logic, some functionality that can be used cross-service. This can be done with a library, but there are other ways. So about infrastructure. One of the things that is commonly done is to have just a jump start, basically a command that you can run, and basically it spins the basics of what is your service. But still, this has an issue because the underlying layer, it changes. If it ever changes and you are using just a jump start, whenever they change, you'll need to change every single service because basically the underlying layer is not a living component. So what I'll suggest is also another library that you can update, and you provide like a simple common API basically that orchestrates everything that is needed by your cluster of microservices. And basically, if you ever have to change how something works beneath, you just update the library. You update the library everywhere in the same way that you do for the contracts. And basically, you have it simplified. You won't forget a service that will probably not happen as easily. So regarding business shared behavior, this is simple, right? This is our common usage of a library. If there's something that we use in different places, you just plug it outside and basically make a dependency or a package or whatever, depending on whatever language you are using. So, but one important thing about this kind of libraries is don't allow them to grow, because something that actually happens a lot when we are using microservice is basically those libraries, they grow bigger than the actual microservices. And then you are actually maintaining the library as a monolith, not the microservices. And that's actually a big issue that happens a lot. So about the infrastructure complexity. This is mostly how we manage our cluster, right? So if we are using microservices, we'll be creating microservice a lot. Like you'll start with 5, then when you see yourself, you are like 100 microservice from nowhere. So you want to be able to create a microservice in about 5 minutes and have it in production. No business logic, of course, but basically compliant with your basic infrastructure layer. Logging, health checks, whatever. I already mentioned most of them, so that's it. So this goes in conjunction with what I said before about having that kind of library that basically offers all that by default, and basically you just initialize all the connectors that you need, and you basically do wiring instead of re-implementing everything. So the big goal here about complexity is that we are spending our time implementing our business logic, not reinventing the wheel, spinning a new microservice and doing everything once again. Another thing that is really important is to be able to test as much as possible together. Basically, if we have solid contracts, we might be able to avoid this, but it's pretty easy to screw up in some ends, and basically, since they are supposed to work together, basically missing some request somewhere or some message, it might screw the whole flow between all the services and lead to unexpected results. So it's really important at a very basic level, at least, to be able to get everything together, even just say, okay, my main flows are this and that, so I'll test them manually and try to evolve from there. Basically, try to create on that same infrastructure, tests that go end to end to your main flows at least, and then try to implement them on your deployment pipeline. Talking about deployment pipeline, this is something that I actually think it's completely unavoidable to have when you are working with microservice. When you start to have 100 microservices to deploy, releases just don't work. You need to basically, oh, I update this service, then I need to update this one, and now this one. So basically, you need to have a simple way to say, okay, I made these changes, just update them continuously. Basically, it's CI/CD. Most of you probably already heard about it. I won't go really deep, but yeah, it's really important to have this kind of deployment pipeline and be sure that testing is included on the pipeline before deploying to make sure no incidents are happening live. So the last big issue is dependency tracking. So the simplest way to do it without cost besides hours is keeping good documentation. But as you grow, that's actually quite hard to maintain because you can basically track relations between 4 or 5, but it's really hard to maintain when the service start to be coupled. One thing that might help here is to basically have microservice architecture inside your microservice architecture. Basically, you define simple clusters inside your microservices that basically can't talk with anything else besides their mini cluster. And you have one of them that's actually the one that is responsible to communicate with the other clusters. And that might simplify you keep the documentation, but it's still quite hard. So if you reach that point, there are tools that allow you to actually track transactions from point to point. And this will be built into the base service that we talked before. So everything is already wired, and basically it just reads your service name and it appears there. Okay, this requested that service name, so there's a couple here, and you can easily get a graph of everything that is talking to each other. That's mostly it. Thank you for your time.